The price of success is hard work, dedication to the job at hand, and the determination that whether we win or lose, we have applied the best of ourselves to the task at hand. Dear academicians and technocrats, a very good morning and warm welcome on behalf of IFET College of Engineering to everyone present today. Our event for today will surely give us a lot of learning about the recent trends in machine learning for neuroimaging. Enjoy the rest of the morning. It is my delight to be your MC today for this informative seminar. I am Hemalata and I am very happy to welcome you all to this session. We hope you will find the program we have lined up for you to be fruitful and engaging. Prayer is not asking, prayer is putting oneself in the hands of God and listening to His voice in the depth of our heart. We'll begin this occasion with a prayer.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः
With a blissful heart, I welcome you all once again. To kick off this morning's program, we are pleased to have with us our very one Professor Giridharan, our co-convener, to deliver the welcome address.
The blossom from the bottom of a rhapsodic
bottom of
heart.
a rhapsodic
On
heart.
behalf of
On
Computer
behalf
Science,
of Computer Science,
Engineering and Information
Engineering and
Technology
Information
Department,
Technology Department,
IFT College of
IFT
Engineering,
College of Engineering,
I take
I
extraordinary
take
pleasure
extraordinary
in welcoming
pleasure
all
in
of you
welcoming all of you
to the 2 days
to
national
the
level
2 days
seminar
national
on
level
recent
seminar
trends in
on
machine
recent
learning
trends
for
in machine learning
neuroimaging.
for neuroimaging.
I welcome our vibrant
I
principal,
welcome our
Dr.
vibrant principal, Dr.
G. Mahendran,
G.
whose
Mahendran,
constant support and
whose constant
encouragement
support and
made us
encouragement
this achievement
made us this
milestone.
achievement
My
milestone.
heartiest
My
welcome to the
heartiest
Dean Academics,
welcome to the
Dr.
Dean
S.
Academics,
Matilda,
Dr. S. Matilda,
Head R&D,
Head
heads of
R&D,
various departments,
heads of various departments,
professors, and faculty
professors,
members.
and faculty members.
Speak Kanimudi,
Speak
IT
Kanimudi,
Department HOD,
IT Department HOD,
Professor J. Jayachitra,
Professor J.
who
Jayachitra,
steers us in
who steers
organizing this
us in
seminar.
organizing this seminar.
A very cordial
A
welcome
very
to the
cordial welcome
guest
to the
speakers and
guest speakers
participants
and participants
who are here to
who are
participate
here
in
to
the
participate in
exemplary
the
event.
exemplary event.
Welcome on and all.
Welcome on and all.
Thank you.
Thank you.
Thank you so much, sir.
Thank you so much, sir.
Before we proceed to the
Before
first
we
session,
proceed to the
we
first
have some
session,
general
we have some
instructions.
general
We
instructions.
request the
We
participants
request the
to
participants
kindly
to
turn off the camera
kindly turn
and
off the
mic during
camera
the session.
and mic during the session.
Participants,
Excuse
if you
me,
have
ma'am.
any
If you have any
questions,
questions,
please raise your hand.
please
Or
raise
from
your
the
hand.
chat
Or
box.
from the
We
chat
will bring
box.
them up at the
We
end
will
of
bring
the
them up
session.
at the end of the
And
session.
please fill the
And
feedback
please
form
fill the
that will
feedback
be
form
posted in the
that will be
chat box
posted in the
at the
chat
end of
box at the end
every
of
session.
every session.
Madam, please check once.
Profession 1 will be
Profession
on
one will be
Introduction to
on
Deep Learning in
Introduction to Deep
Neuroimaging.
Learning in
It will be
Neuroimaging.
handled by
It will be
Dr.
Madam, there is an
handled
echo
by
problem.
Dr.
There is an
Shruti
echo
Madam,
Pandey,
problem.
excuse me,
TRI
madam,
University,
excuse me,
TRI
madam,
Kolkata.
excuse me,
University,
please.
Kolkata.
Madam, excuse me,
I'm
please.
very happy in
I'm very
Madam,
introducing
happy
our
in
vibrant
introducing
resource
our
person.
vibrant resource person.
madam,
It gives me immense
madam.
It
pleasure
gives me
in
immense
introducing
pleasure
our
in
resource
introducing our
person,
resource person,
Dr.
Dr.
Doc- Dr.
Doc-
Abhishek K.
Dr.
Pandey from
Abhishek K. Pandey from
Hello, sir.
Hello, sir.
Thank you so much, ma'am. I'm hearing you, but there is some echo issue, I guess. If I'm audible, let me know.
You are clear, sir. No issue with you.
Yes, sir. Voice audible, sir.
Okay. So thank you very much, everyone. And first of all, I would like to extend my gratitude to IFET College of Engineering for organizing such a great event with lots of great dignitaries and faculties and PhD scholars and MTech scholars as well, I'm sure. So first of all, I want to know that if I'm going to start this, and let me finish this first, and I'll finish it by 11:15. Then I'll have some interaction session. You can ask me any question if you're having. If you are
Sorry,
doing,
participants, for the network issues. We'll resolve them and connect with you soon. Kindly be in meet, please.
am I audible?
Yes, sir. Please continue, sir. Yes.
So should I continue, sir?
Yeah, yes, sir. Please continue, sir. Please continue.
Oh, okay. Actually, in the middle of, I got
Yeah,
some
sorry,
voice
sorry.
from, yeah.
Yeah. Sorry for convenience.
Okay,
Start, sir.
not an issue, not an issue, sir. So should I start? I share my PPT and everything. Fine, sir. So, welcome to the very first session of this workshop or this seminar, which is supposed to cover the basics of neuroimaging. So, thank you again, the organizer, for organizing such a beautiful event, so that lots of researcher and faculties and dignitaries can meet on a single platform and they can share their knowledge. So, I'm not here to, something like teach you or something like that. I'm here to share my vision regarding neuroimaging. So let's start with the session. I'll start with deep learning to neuroimaging technique. So first of all, I would like to say that basically image processing or neuroimage techniques are almost same, regardless the techniques and the different terminologies and different functions, whatever we are using in, whether it is MATLAB or whether it is Python or whether it is any kind of platform which we are having like OpenCV and other. The point is when we have to analyze neural time series data, fine. So basically we are working on data. So I will also share a doc file with you by because I cannot able to share the descriptive things on the topic. So I will share that doc file with you also to get it more clear. So when we are talking about neuroimage, first of all, we have to analyze neural time series data like that. So first of all, what is neuroimaging? So how we can explain that what is neuroimage? So basically the things which will tends us to explain that how the brain works and how activities impact the brain. That's the main thing is. So neuroimaging is basically a branch of medical imaging only, whether it is tuberculosis, whether it is liver cells data, whether it is veins data. So it is basically a branch of medical imaging. It is a branch of medical image processing that focuses on the brain part only. That's the main concept is. So my point here is to explain that what is neuroimaging, and it is explained in one line that it is a branch of medical imaging that focuses on the brain and how brain is working. So we can get all those things. So in addition of diagnosing disease, accessing the brain health, neuroimaging also studying how brain is working. Getting my point? So basically, it is not even proved right now because AI is considered into next generation computer generation. That's why it is also a very sought to be research topic. So many work can be done, and many work has been done, and many work can be done in the future aspects also in coming 10 or 20 years. What I think. So basically, we have to start with what is neuroimaging. So let's start with the introduction. So we have artificial intelligence, means what machines can do but humans cannot. That is my definition of artificial intelligence, what machines can do but humans cannot. It is debatable, but it is not relevant to explain it or debate over that topic for now. We will discuss it some other time. Second thing is, what is machine learning, what is deep learning, why machine learning is not appropriate, why machine learning is not relevant, why machine learning is not self-compact. That's why we need to jump to the deep learning concepts, to deep learning techniques. What is radiology with deep learning? So deep learning, radiology is the biggest concept. So Alan Turing, we all know, he was the person who has actually done the astrology that after 12 years there will be some device which will be called computer or something like that in 1936 only. So he is the person behind this, and he has devised Turing machine, which we have gone through within compiler design and theory of computation also. So artificial intelligence, the ability of digital computer or computer controlled robot to perform tasks commonly associated with intelligent being. So this could be the secondary thing. First of all, what I think during my master's and during my PhD, that is a machine can do, but humans cannot. That is only AI. Fine. So basically, it is dependent on, I'll start it from learning and training. So domesticating a dog, and we will go through with the feeding a child with a spoon. So if we are feeding a child with a spoon, we are always tends to, make them understand that you have to take that feeding material into your mouth only. You have to get the spoon contented with the feeding material and get into your mouth only. But if we are training them to feed or to put that spoon into their ears, they are trained to get that like that. So basically, there is a threaded line difference between learning and training. But if we are talking about intelligence, as it is appeared on your screen, all but the simplest human behavior is ascribed to intelligence. Fine. So the second thing, if we can ask that, what is intelligence and what is artificial intelligence? Fine. So intelligence is something which we have gone naturally by God, and we are nowhere artificially around that. Even if we are having artificial neuron, even if we are having all the techniques. So the ability to understand, the ability to learn, the ability to think, which is very natural as far as it is not artificial intelligence. Fine. So if I'll ask, what is your definition of intelligence? So it would be like to get skilled, use a reason, the ability to apply knowledge, to manipulate environment around you. Fine. The things which is abstract, which can be felt only, which can be felt only. So these kind of things can be explained by using intelligence. Fine. So a very general mental capability. But when it is artificial intelligence, when it is AI, so it could be something like that which machines can do, but humans cannot. Definitely. Otherwise, what is difference between AI and normal AI? Fine. So we can have a discussion over this also. So personalized recommendation, if you need to provide to some people based on examples of previous searches, based on the examples of past experience, fine. So it could come under the category of data mining. It could come under the category of machine learning. It could come under the category of AI. It could come under the category of computer vision. It could come under the category of image processing, and like that only. So basically, I'm not able to differentiate as far as the working is concerned between these. These all techniques, these all algorithms, these wider area having are working on the past experience. Suppose if we are supposed to recognize some face with some other faces, so we are supposed to have some database before. So suppose I have to recognize my face from my face, and if we are having two images, one is as training set and other is at test set, and one image is having black and white feature, and other is having RGB feature or colored feature. So can that computer or can that trained system able to detect it right? I don't think so. I am the same person, I have the same features, but a general person who is having real intelligence, gifted intelligence by Almighty, so they are able to detect it, that this is the same person having mustache, this is the same person who has removed his mustache or something like that. But if it is artificial intelligence, so that could be the greatest challenge we can ever have. You also have got to know that artificial intelligence was, very much popular, and it was very much into the shape in 1956 only. Fine, but it is not very structured. It is not very much used in offices and in any labs also, until or unless it was having back propagation algorithm till 70s. So in 1970, it was almost decided to eliminate this artificial intelligence and get something else in place of it. So they certainly got this back propagation algorithm, so that we need some training or learning algorithm to train the data, to train the system that how to do this. Otherwise, it would be a body without soul. Getting my point? So sorry if I'm getting very much back in the history and where the things got started from. That's why my point is to get into it. Fine. So there is intelligence and there is a learning. So I have just explained what is learning. Whatever you try to make the system or make the person learn from you, it is learning. It is a process that leads to change. Fine. So if we are talking about learning in artificial manner, so what it would be? Fine. So how we can know that artificial intelligence is doing learning by which method, or how we will do it? Just like we do in a real system, like to get it learned from the society, the environment we are having. So learning is a process of acquiring new understanding. So feeding a child with a spoon is the best example, which you can get from the Bible book of the artificial intelligence, that is Russell book. So you can get that example from there. The whole topic is from there only. Fine. So learning is the process of acquiring new understanding, knowledge, behaviors, skill, values, attitudes, and preferences. But just now I have explained that where we are stuck in. So we are having, iPhone, we are having, different level of technology right now. But is it artificial intelligence according to you? Anyone, can you answer in the chat box? Is it artificial intelligence what we are using according to you? Anyone who is agreeing that we are using artificial intelligence? Anyone? With all due respect. Are we using artificial intelligence? The answer is no, actually, according to me. It is going to occur, it is going to happen in next 20 years or 25 years, what I think. Yes, Priti ma'am, we are not using it. Actually, what we are doing, we are going with intelligent system. We are training it and we are getting it whatever is required. That we were doing in data structure also, if we are talking about algorithm. So if we are talking about algorithm, what it is doing, suppose we are having 5 numbers to sort, and we are doing it sort by manually, it is possible. But when we are having 500 or 5 million or 5 trillion number to get sort, Is it possible to sort it manually? And will it certainly give some results? No, it will not. No, it will not. It won't. Why? Because the data is very much dense, the data is very much bulky. So we need to jump to some algorithm which can solve the problem in a fraction of seconds. Fine. So that's the thing we are doing here also. We are making an intelligent system. We are training it that this could be some cases. If we are not getting into it with some that particular cases, we are getting the wrong answer. So this is not AI. This is not intelligence we are calling. This is not at all an intelligence. So problem solving is a very important aspect, and the problem solving agent performs precisely by defining problem and with several solutions they are having. Fine. So basically, now from image processing and AI, we need to jump to deep learning. Fine. So deep learning is an extension of machine learning only, and it is a type of machine learning and artificial intelligence, we can say, that imitates the way of human gain certain types of knowledge. So if we are having bigger data, like we were having data mining, then we were having big data also. We were having machine learning, and we are having deep learning also. So if we are sorting any number, try to understand my point of view. If we are sorting any 5 numbers by using some algorithm, so we are wasting our time, we are wasting our money, we are wasting the manpower. So if we are having some 500, 5,000, 5 lakhs or 5 million data to sort, and we are applying algorithm, then only we are justifying that algorithm. Similarly, if we are moving into deep learning, fine, so we need to have some bulky data. So if we are having bulky data, then only deep learning algorithms can work very well. Fine. So this is a very common, example which we are having. So if we are talking about artificial intelligence, if we are talking about any artificial intelligence, so a program that can sense, react, act, and adapt. That is the one thing. Machine learning, whose performance improve as they are exposed to more data over time. At the same time, deep learning, a subset of machine learning in which multi-layered neural network, I repeat, neural word is being used in deep learning only, multi-layered neural network learn from vast amount of data. That's the basic and the only difference, apart from many differences which we are having for theory classes. But if we need to learn it, this is the basic difference we are having. Fine. So basically, deep learning is a subtype of machine learning in which multi-layered neural network learned getting there from the vast amount of data. So the vast amount of data need to be underlined. So the next question is machine learning is ML or AI? Or deep learning is ML or AI? So deep learning is a subset of machine learning, as we have discussed, and machine learning is a subset of AI actually. So it is basically a term in a computer program that does something smart. So basically we are tend to have a intelligent system. So we are stuck into it. That is what intelligent system is all about. So in other words, you can say all machine learning is AI, agree, but all AI is machine learning, that is debatable. Fine, it could be data mining, it could be something else, fine, and so forth. So if we are doing it in MATLAB, or if we are doing it in Python, or if we are doing it in any other tool, we need to follow some basic points that we have to pre-process the thing, the 7 stages of image processing what we are having. Fine. So how deep learning works and how machine learning works, as we have said that how deep learning works and how machine learning works. Then we will move to the neuroimaging part. Fine. So according to it, I mean, if we have been asked that what is neuroimaging, fine. What is radiology? So we have some points to get started with. So what is clinical research? How neuroimaging is very helpful when we are having, I mean, COVID blast throughout us. Fine. So there is a term, I mean, that is, MRI and MRS, that magnetic resonance spectroscopy. So it allows actually the researcher to obtain biochemical information from the brain. What MRS is all about. So it uses a neuroimaging technique basically which is called magnetic resonance spectroscopy. So basically MRS is a neuroimaging technique which is totally used for biochemical information obtaining. So when we are having those attributes, so while magnetic resonance imaging we were using before, MRI, magnetic resonance imaging, so it only provides about brain structure. Getting my point? That's why we are jumping into neuroimaging. First of all, we have gone through with language C. The language C was having some issues where we have jumped to C++. That was having some issue. We have jumped to Java. So here also the story is when MRI is not capable of giving the whole picture to the researcher, to the doctors, then only there is a technique which is called neuroimaging, which got into the picture. Fine. And how you are using it, because the data is so bulky, we have to go for deep learning only. It will be a good programming practice to go with deep learning, whether you are going on Python, whether you are going on MATLAB. Fine. So basically the magnetic resonance spectroscopy, that is MRS, is capable of being tuned to pick up the signals difference before, I mean, the chemical difference before the, before the signals we are having. So in order to pick up signals from different chemical nuclei within the brain is not a very easy job. That's why we need something which is a very strong algorithm. So machine learning was not capable enough to get into the whole classification exactly. So you can see in the slide also, we are having input, and machine learning is doing feature extraction first of all, like other techniques, then the classification, and then there is a recognition that whether there is a this is a car or this is not a car. Getting my point? Then there we are having input. The feature extraction and classification is getting done at the same time with multiple layers we are having in deep learning. So it is providing the capable techniques it is having, the strong techniques it is having, but if the data set is not compatible with the technique, it will always be a waste of time. Always remember. So we should not prefer this kind of thing when we are having less amount of data, and if the data is not very much compatible with the technique. So whether it is car and whether it is not a car, that would be the different thing, but the process in the middle, it is getting done. That is the most important part. Fine. So basically what MRS is basically a neuroimaging technique. Basically MRS is a neuroimaging technique. So it is invasive magnetic resonance technique that does not use radiation, dear friends. It never use radiations. So it is less risky. So MRS scan are obtained in MRI scanner also, which look like a large cylinder. I'll show you that, with a tube running down the center. Fine. So when we are applying deep learning to it, so when a researcher or when a study participant receives a MRI scan, so they are asked to lie down on the on their back, and Just like MRI, it is getting done. But what would be the output in that case? What is the role of radiology in that case? That would be the things to be look for. Fine. So when we are talking about deep learning also, or we are talking about neural network also, so it is basically based on three processes. Like before it was done, the first process is acquisitions. Fine. The first process is acquisitions. The second process is processing, and the third process is display. So acquisition is what I have just discussed with you. So the patient will sit, or the person who is having some issue, he is going to sit, or he should be, sleep over his back, and then we will start the processing, and then finally we are having display over it. So it has always been the major aim of neuroimaging to achieve the greatest possible resolution. Always remember that. So in order to achieve greatest possible resolution, we are tends to follow deep learning modules and techniques. Fine. The cognitive operation of interest to this, neuroscientist we are doing this only. So the basic thing which I need to discuss with you, it is a type of advanced machine learning algorithm known as artificial neural network. So we are basically looking for what is the role of neural network when we are doing neuroimaging with the deep learning concepts, whether it is you are doing it on MATLAB or where it is not MATLAB. So deep learning may sometimes be referred as deep neural learning or deep neural networking. So don't get confused when somebody will discuss that what is deep neural learning and what is deep neural networking. So it is the same thing we are having. So the point is, the basis of all the reconstruction techniques which we have to follow, like in machine learning, like in image processing, like in artificial intelligence thing we are doing. So the basis of all those reconstruction techniques is the synthesis of three-dimension image of the series. So first of all, we need to go for two-dimension image, or projection we are having. So we have, what we have to do, we have various angles data we have to take, and then we have to follow it like that. Fine. In CT, for example, in computation terminology, in CT, for example, a slab of tissue is penetrated. Fine. Similarly, I have discussed the MRI thing with you. Similarly, I have discussed the MRS thing with you. Fine. So the conclusion is, what conclusion we are having? So whether it is Alzheimer's disease, whether it is Parkinson disease, whether it is MRI, whether it is neuroimaging specifically. So when CT, CME, MRI, MRI also, if they are not able to get the right picture of the patient or of the target image, then only in general it is preferable to perform neuroimaging with MRI than to perform CT with contrast medium enhancement. Fine. So MRI is more sensitive, but in case of neuroimaging only, it is MRS only, which is getting the right image or right accuracy comparatively. So neuro image can better evaluated by MRS. That's my point of view, what I have gone through with in sorry, in my research also. CT is useful in patients who cannot undergo MRI, or when MRI is not readily available, then only we are preferring CT. So this is my basic thing which we have to discuss for now. Now, deep learning examples we have to see. So why I have used Alan Turing name, because natural language processing is the basic scenario we are having when we are dealing with deep learning. So the first part is image recognition. The second part is natural processing language. The third part is portfolio management and prediction of a stock price movement. So there are lots of examples. The next slide will tell the better picture that why deep learning and why neuroimaging. So here is the answer. And we have already discussed this. Why neuroimaging? Why MRS? I'm so sorry for inconveniences. I'll share that PPT for sure. First of all, I need your input from your side also, sir, so that I can improve it in a better way. Fine. So basically, we need to follow end-to-end training, and we need to follow visualization as far as MRI is concerned. So basically, feature extraction and classifier is getting done with the same time, at the same time. That is the future of deep learning. Fine. When we are doing final diagnosis, it should be based on end-to-end training and statistical analysis. Always remember. Where did we get that statistical analysis from? It will always be got from, features only, which we have extracted. So it is called demographic data, what I have explained in cognitive or clinical test score. So this is what we were having if we are talking about deep learning and neuroimaging. So whenever you will open deep learning modules, you have to download the deep learning modules, and you have to download the 2020 version at least for the MATLAB. Then only you would be able to run these new applications. In previous version till 2019 also it is not getting run. So if you have to start with it, if you want it to get familiar with you, and if you want to get familiar with deep learning concepts, you have to start with MATLAB. I preferably suggest you to go for MATLAB first and then for Python, because once you are getting into Python, you cannot get the basic constituent that how it is working. MATLAB will tell you exactly that how it is working, what we have to do, where acquisition is getting take place, where pre-processing is getting take place, where the display of image is getting take place. Exactly, you would be able to know everything. Fine. So as I have discussed with you that a growing number of clinical application based on machine learning and deep learning pertaining to radiology. So I need to explain that what is radiology and why it is not prefer and why neuroimaging is preferred, because it is not based on radioactive signals, so it is less risky. So radiology also is a branch of medicine that uses image technology, whether it is neuroimaging, whether it is any general medical imaging. So it is supposed to diagnose and treat disease, whether it is Alzheimer, whether it is Parkinson, whether it is brain tumor. So radiology may be divided into two different areas. The first one is diagnostic radiology, and the second one is interventional radiology. So basically, the radiologists who are supposed to work over it, they are basically looking for neuroimaging only to get the right data to them so that they can able to get at some decision. Fine. So a variety of imaging techniques such as X-ray, radiography, ultrasound, computed tomography, nuclear medicine, including PET, what we have basically done in MATLAB, positron emission tomography, PET, then MRI finally, then MRS. So they all used to diagnose or treat disease. Then the question is, what is neuroimaging is doing here? I have already explained you. It is list based on the radioactive signals, and it is capable of getting all those data which is MRI is not able to give. So the modern practice of radiology involves several different healthcare professions working team. So engineers are working with the doctors, Fine. Researchers are also working with the doctors. So these are getting much more, wide. Fine. So basically, whenever we are getting into image processing with MATLAB or image processing with Python, we are performing pre-processing, we are performing classification, we are performing segmentation, because we need to focus on some specific area. So we need to set some threshold that we will not get over this area. We will focus on the area which is being infected. That is all about segmentation and threshold, if I'm talking in a very non-technical way. If we don't want to focus on the area which tends not to be in your research domain, so it is just like anomalies, it is just like outliers, it is just like the thing which is not meant to be done. That's why we have made, we will go for segmentation, and that's why we will set the threshold value, which is always been set randomly by the programmers, whether you are working on Python or whether you are working on MATLAB also. Fine. So if we are doing task diagnosis or prognosis or even prediction of therapy responses, we have to go for deep learning concepts. So your question could be whether, is the capability is the only reason we are going for it? No, apart from capability, there are various technical reasons which I have discussed with you. Fine. Suppose we are having a biological network, and we are having those network, and we are supposed to get it through machine learning. So it is not possible actually. Fine. Why it is not possible? I'm just telling you. Let me escape it from PPT, which is not showing you the right picture. So what I will do, I'll share a new file with you. That is this top file. So now you can able to see that, how neuroimaging has been done and what it is showing. Fine. So just have a look over it, then I'll share everything with you. What I have got to know, that only. With all due respect, I'm saying again and again. So these are the key points I'm having. So whatever is highlighted thing, this is called the neuroimaging or brain scanning, includes uses of various techniques to either directly or indirectly image the structure, function, pharmacology of the brain. What you need to understand that why we are using neuroimaging for a specific purpose, for this only. Getting my point? For this only, for nothing else. Fine. This is a single line answer. How it is appearing? So appearing like MRI only. You cannot really differentiate. But how it is appearing? A researcher, a doctor can better tell you. So neuroimaging falls into two broad categories: structure and functional. Fine. So this is the summary: structural and function. So EEG is used to show brain activity, that we all know, under the certain psychological states with some attributes or some parameters such as alertness or drowsiness. Fine. So these could be the attributes for instant of time. Fine. Then we are having PET, what I have just discussed with you. So it basically scans so brain processes by using the sugar glucose. So this is the attribute. Getting my point? Even if we are going for some papers, whether it is for review paper or some results, so these are the things we need to follow in data sets also. What you are downloading it from Kaggle or whether it is downloading it from IEEE websites. So in the brain, to illustrate where neurons are firing. So we have to get where neurons are firing. That's the thing is. Then in case of MRI and MRS, which is very important. MRI or MRS. So these scans uses echo waves. Very much safe. Echo wave, no radiation. That's fine. So it will use this attribute to discriminate among gray matter, white matter, and cerebrospinal fluid. So these are the attributes in this case only. You're getting my point. So whenever we are trying to recognize something based on the past experiences or based on the data sets, we first need to pre-process those data sets. So whether it is neuroimaging, whether it is any kind of medical imaging, but in case of neuroimaging, these minute techniques and these minute attributes should be taken care of, and that's why we need deep learning. That's why only we need deep learning, so that we can have some good structure out of it. If I would not have the right structure of my students who are supposed to be in my class, how I can say that this student is good or bad? It is just like that. Getting my point? If I'm not supposed to have some data that when the weather is, getting changed, or when the weather is behaved, how I can predict that today weather could be like that? Many times weather predictors or weather prediction government office has been failed. They cannot predict tsunami, they cannot predict exactly many floods, because it is not very mentored, it is not very well learned, it is not very authenticated technique. It is a prediction and classification only. Even if you are using deep learning, it is prediction and classification only. We cannot say that this is gonna happen for sure. We are saying it is classified that this is gonna be happen. It is predicted that the stock market is getting work for today or for next 1 week. Fine. So basically we are having these things. So the last point is functional. Whatever we have gone through with was a structural. Now we are having functional magnetic resonance imaging. So now we are having exactly neuroimaging technique, which will need very much large attributes to get at the large picture. So you can able to get all those data which are supposed to have. Fine. So basically, if we are saying what are two categories that we have gone for, so those categories are this only. It is on your computer screen. So these are the two categories we are having. I would like to explain it to you. Only this, structural imaging and functional imaging. You would be able to understand that what is structural, which deals with the structure of the brain, which was done before also, and diagnosis of the large scale intracranial disease such as tumor, such as injury, internal bleeding. So it was done before also, and very efficiently it was done. So it is being considered this time also in neuroimaging. But apart from that, we are having functional imaging also. So in case we are having functional imaging, which is used to diagnose metabolic disease and listen on a finer scale, such as Alzheimer's disease, which is having a maximum attributes we can have on any data sets. It could be this feature also, it could be this feature also. So in that case, we need something which is showing functional imaging. That's how neuroimaging got into the picture. So we have to visualize the braining internal information directly. We need to get into neuroimaging. Neuroimaging data is so vast, the attributes are such, we need to have some proper or a strong algorithm. That's why we cannot rely on machine learning only. We have to opt for deep learning algorithm. Fine. So we have to go for nuclei data also. We have to go for different biochemicals also. So how it is possible to get it through PET or MRI or anything which is less than MRS. So MRS is perfectly matched the brain structure and function. Fine. So we have to focus on neural tube. We have to focus on that. Apart from that, we are having many attributes which need to be taken care of. Fine. So deep learning in medical imaging, focusing on MRI. So MRI was done before also. So what happened in machine learning, basically, and what does it mean for the future of medical image analysis? That is the main question. I would like to put this in front of you so that many guides and many researchers can think about it, and if they will think about it, they could have better picture that this is gonna happen. It is in yellow. So what has happened in machine learning lately, and what does it mean for the future for medical image analysis? If we are doing or we are dealing with expert system only, then what is the point of these different tools we are having? So we can say that machine learning has witnessed a tremendous amount of attention over the last few years. Agree with me? So the current boom is stated that after 2009, when so-called deep learning artificial neural network began, it basically began after 2009. Fine. There is a question from Prasant sir, whether functional imaging can be carried out in retina nervous system for Alzheimer disease. Of course, it can be. It can be carried out, Prasant sir, but we have to change something in the attributes we are taking. So if the attributes are less in deep learning, Prasant sir, it would never give a very good results to you. You can do it in machine learning also. But what is my point? If we are having those attributes or those number of attributes which machine learning is failed to get, then only we can go for functional imaging with deep learning concepts. Otherwise, if it is only functional, we need not to go for deep learning, according to me. I mean, it is not a very fruitful. If we are having both concepts with us, that we need to give the functional and structural, then we can go for it. Then the second question is from Jute, sir. The question is it possible to go with machine learning techniques for feature extraction and selection, then go for deep learning for classification, medical image, disease detection? Yes, it is possible, Jude, but what you will explain to your guide and what you will explain to the panel when they will ask that you have taken 4 subjects exam from your 4 students and you have taken 5 subjects exam from other 5 students to get at some results. So parameters should be the same if you are dealing with the things. Fine. So if you are comparing the things before, only it was done with machine learning. So you have to go with machine learning and deep learning also, that this work has been done in machine learning and I am giving the best result out of it comparatively. But if it is not working on the same parameter you are working on, then it is not a good feature to go with. Because if you are having, Jude, if you are having a very less data sets, then only you should preferably go for machine learning. If you are having a very bulky data sets, machine learning is not applicable over it and deep learning is only used for it. If you are having not bulky data set, deep learning is not worth to go further with, according to me. Yeah, based on data sets. See, everyone right over here, I have a question and I have an observation regarding deep learning and deep learning algorithms. Whether it is on oral cancer, whether it is on cancer data, whether it is on COVID-19 data, you'd always see that they have never proposed a new algorithm. They have just changed the parameters of deep learning. They have just changed the layers of deep learning in any paper you have gone through with. So I'm yet to have some new algorithm in deep learning, like machine learning algorithms. They have proposed many things. Fine. But in deep learning, they have never proposed, no researcher have proposed a new algorithm novelty. What they have done the things changed in the data sets. That the previous data set was not having this attribute. I'm taking this attribute also, and we are getting you some results also. I mean, Tell me if you are not agree with me and tell me if you agree with me. Is it, observed by you also that I have not been found yet some algorithm like in DSA we were having prims and Kruskal for the same thing. In machine learning, we were having PCA, LDA for the same thing. But in deep learning, we are having very, specific things, very general things, sorry, not specific. And every researcher is going with that only. Yeah. Yeah. So, Priti, if you are partially agree, you just send me some papers which are having some novelty algorithm. I would certainly let you know they have done nothing as far as novelty is concerned. For the sake of things they have done that, but you will not agree if you will go along with the content of technical things. You would also not agree with that. This things has been done before. The same question will haunt you like it haunts me also. Fine, Priti. Fine. So basically, deep neural network are now this after 2009 scenario. So deep neural network are now the state of art machine learning models across the variety of areas, right from image analysis to NLP, natural language processing, and widely deployed in academia and industry. What I'm telling you, deep learning a story in 2009. Fine. So basically the medical data analysis and medical diagnosis or healthcare in general, whether it is used for Alzheimer or whether it is used for brain tumor or whether it is used for liver diagnosis or any kind of thing. So it is slowly being realized that it is very specific to use if we need some structure and functional things together. Fine. So I am trying to provide a short overview of recent advances, some associated challenges in machine learning applied to medical image processing and image analysis. That's my point is only so that you can get familiar, and for the upcoming sessions you would be able to apply and see the things that what they are saying and what they are discussed. So as this deep learning or as this domain become very broad and fast expanding field, we will not say survey of the entire landscape of the applications for now, but we have to focus on deep learning in MRI. Basically, how deep learning in MRI has changed to deep learning in MRS. Fine. So my aim is threefold. Give a brief introduction to deep learning with pointer of core references. Fine. What I have discussed with you. So Preeti has said that she is partially agree. So I asked for some papers so that I could also get educated that what have been done. There is a question, Deepak. It is advisable to go with real-time data collected from hospitals or to go with available data sets like OSIS and Deepak, if it is real-time data, trust me, if the analysis is okay also, you can get Nature publisher for publishing your paper if it is real-time data, and if hospital is getting you permission that you can use it, they will use their name also in place of author or in place of if it is patent filing. Fine. So you can see when we are working on Alzheimer data, even I have worked on Alzheimer data, so I have to take permission from Alzheimer Institute America, and they have asked to get them as author name or corresponding author name in the paper which we were working on. So that paper could have better impact for sure. We have to go for real data until or unless somebody is allowing you to use that. So if they are allowing you to use that, you can easily get any high impact factor journal for your work, Deepak. Yeah. So we have to indicate how deep learning has been applied to entire MRI processing chain. So how it is getting converted from MRI to MRS. Fine. So these are the things we are having. So deep learning basically rose to its prominent position in computer vision. Getting my point? The slide was saying that only. So when neural network start outperforming other methods on several high profile image analysis benchmark, so only neural network is getting into picture in that case. So most famously, ImageNet large scale visual recognition challenge, which was done in 2012. This deep learning was done in 2009, so it was done in 2012. So when there is a deep learning model, or you can say CNN. So on the name of deep learning model, we are having CNN only, Preeti. That's why I have said. Fine. By they have provided by deep learning also, deep learning by themselves also. We are not having that. So we are opt to change something in that without getting into parameters proved is not very much satisfying thing for me. That's what I have said. I may stick to my point, and I would like to have something which has been done so that I can explain my vision to you also. So half the second best error rate on the image classification task, we can get better classification. Fine. So basically we are enabling computer to recognize objects in natural image. That's the Deepak question for you. That whether we should work on real-time image, if that work is having social sustainability, fine. If it is, you can get any kind of DST projects for you. If it is worked on agriculture, if it will work on real-time thing, you can have a very real-time work then. Then that is the, I mean, really, appreciable for the researcher. Fine. So I would like to suggest to go for only real-time data. Fine. So this is the thing we are having in this segment, and if we are have to go for image study provides, biological insights also. Yes, it is providing biological insights also. Fine. So these these are the things we are having. Then you can get to know. Then the things will get very much vast and very much advanced. Then neuroimaging is totally based on MRS until 2018 and 19. In 2020 or till right from 2020 to 2022, it is MRS only. Fine, it was MRS only. So it has been playing an important role, even MRI, in understanding brain functionalities. So not only understanding the brain functionalities, also the disorders during the last couple of decades, since when it is getting into the picture. So these cutting edge MRI scans supported high performance computation, which is not possible in machine learning. That's why deep learning, my dear friends, we are using high performance computation tools and novel machine learning techniques have opened the possibility to get those data which was not possible to get before. Fine, to identify the neurological disorders, and they have been done. The work has been done before also, right from 2020. However, there could be some debate over it. Fine. However, similarity in disease makes it very difficult to detect that whether this disorder is, from neuroimaging data or it is neuro-related only. Fine. So when we are focusing on Alzheimer's disease, it critically examines and compare the performance of existing deep learning method. So whenever you are going with any kind of paper, any kind of high impact factor journal paper, it will compare and examine the performance of deep learning based method, which we are having before also. That's my point is. Can we process, and there is a question, can we process or image processing on medical image on our PC with MATLAB or Python? Kalyan sir, yes, we can do that. I have been doing that only. Very less time in India, we are having those, labs or some new tools which can show this. So even if you are training your image or you are training a model, you have to leave your computer for 24 hours to train it, to train it well. If it is train it well only, then only it can give some results, sir. Fine, Kalyan sir. So we need some better server to work on, but we can do this perfectly. I have been teaching image processing for last 5 or 6 years. So I have started it on my PC only, and it is done very much successfully. Fine. So let me get the second question from Preeti, then I'll get back to you. If you are having any question, Kalyan sir, please ask. Kalyan sir, one thing I want to get into picture, if we are working, even if we are working on 3D pixels, even if we are working on 3D pictures, we need to convert it into 2D. Even if we are working on MATLAB or Python, it need to be, converted into 2D. Otherwise, you have always heard about reconstruction or mean of that particular image. That's what I have talked about in the very early session, sir. If you are comparing my image from my image only, or if you are working on medical image also, it is following the same fashion. It is following the same technique. So we need to reconstruct it in a manner so it should be normalized enough to get at the right result. So when we have to normalize it, we have to do it 3D to 2D. Right? You have got me right now. That's why we have converted into 2D, because no model or no tool we are having which is working on 3D directly. Fine. So computer is only understanding 0 and 1, sir, and 3D is having 3 factors, RGB. So it will be, it will do some ambiguity. It will always give some wrong results. So we have to maintain or normalize the illumination condition also. Exactly, we have to do proper pre-processing, sir. In all cases, even if you are doing data mining in Vika, even if you are doing image processing in MATLAB, even if you are analyzing any data on Python, we have to do pre-processing. It is a very obvious thing to do, sir, because computer will never respond, or any model can never respond to 3D model directly, 3D image directly, because they are having more than 2 factors to work on. So it is supposed to be converted into 2D to get it only true and false thing, 1 or 0, whether it is, or it should be in grayscale. So the value will lie between 0 to 1, sir. So then it will also give the right results. Am I okay, sir? Okay. Then there is a question from Preeti. Can we use secondary data set, means like data set used for another problem, and can we use for our problem? It is something like that, Preeti. You want to say that suppose we are doing work on environmental pollution, and we are explaining noise pollution. So I guess this kind of references you are using, so it is not doable, I guess, from my side. Fine. So if you are doing work on Alzheimer, Preeti, so before that only Alzheimer work has to be compared. Otherwise, you cannot able to predict that what work you are working on and how it can be compared. You cannot discriminate between 2 students. You cannot make results on basis of 5 subjects to 1 student, on the basis of 8 subject to other student. That's my point is. The parameter should be same enough to get the right result. If all the students are getting examined on 5 subjects, then only you are deciding that he is a topper or he is not topper. That's my point is. I guess I'm clear to all of you. If there is any question, Preeti, please let me know. Jude sir, any version will work. You can use it any version. There is no specific thing for that. Anaconda or Miniconda. These all are, I mean, popular version you can use it for, and you will never get any issue in that. Fine. So Python is something which can move the mountain also. So it is having very strong learning technique. But again, I would like to request you to go for MATLAB before getting into any other tool, sir, because you will get very familiar when you are using MATLAB. You will get each and every application visible to you, each and every point visible to you, that how it is working. Deepak sir, most of the paper I have recently worked on oral cancer review paper. So we have actually gone through with the more than 250 papers recently, right from 2018 to 2022. So we have taken this accuracy, sensitivity, ROC thing only. So you can take minimum thing, but in the in the review part, you need to check that which paper has done more than this, or which paper has done this only. So most probably you need to evaluate one or two more matrices. Then your 2 or 3 objectives will be clear. If you are a PhD scholar, and if you are a guide also, you can ask your student to increase the parameters or the matrices. Then only you can able to justify that this work has been done by me and we have done this kind of changes. Preeti, that's what I am talking about. They are doing the same thing, but they are using CNN and they are using deep learning. Everyone is doing the same thing. So this is my point of view regarding this. That's what I am talking about. Deepak sir, is it, I mean, satisfactory to you? Okay, thank you. Any other question? PET from MRI, it can be done, ma'am. Or why you are doing contrasting PET from MRI? Why not we are having MRI directly? Because we are having lots of data sets which are having MRI. So use pre-processed data itself if it is not one of your objective in the work. Premlata ma'am. Yeah, if it is not your objective, if it is your objective, you can do the same function of MATLAB, that how to convert it from PET or from MRI. If it is objective, it is a very vast thing. I cannot help it in a, I mean, 5 minutes or 10 minutes in it, ma'am. It is a proper work. So I would rather suggest you to go for MRI-MS database only. That would be much better. Then there is a question from Lavanya: how we predict Alzheimer disease using MRI training and testing, data mining using machine learning, sir? First of all, Lavanya, we cannot use machine learning if your Alzheimer disease datasets is, I have never seen Alzheimer disease datasets so much small that machine learning could be enough to get the right analysis. We have to go for ultimately for deep learning. Fine. So I would prefer you to not to go with the data having on Kaggle. Rather, you have to ask American Institute of Alzheimer to provide you data, work with them, you will get the better results. And you will get many other things getting done for you, and use deep learning, getting into deep learning only. Lavanya, let me know if it is helping. Yeah, any other question? Deepak sir, again, sir, predicting Alzheimer will be advisable for early detection with clarification made at dementia. Will it be advisable for AD? Yes, sir, it is. It is. You are going in a very right direction. It is very much advisable. We can go for it. We can get some analysis out of it, and then we can work over it. So in the thesis part, or in the, I mean, defense part, we can say that this has been done by us, and we have done this before also to check this. Fine. Suppose let me conclude with this simple thing to all the research scholar sitting right here and all the guides sitting right here. Suppose we are not taking 2020 or 2022 paper in our work. Suppose we have taken some conventional algorithm, like which has been proved mathematically also. So we should go to change for that algorithm, not mathematically, but implementation wise. So they will ask two things: whatever you have proposed, whatever, so you need to justify those proposed work, that whether it was done before, whether any paper has said that this problem has been formulated in their work also. If that is done, you are very good, you are going very much in right direction for that particular algorithm. Fine. So you made functions for two things: to support your objective, and then if the objective is supported, if the objective is justified, then only you can go for the implementation on some key. I have implemented this for this kind of data set, and this is getting some, not getting some better results than before comparatively, but it is getting a different view to the system. So the research scholars should be encouraged to do that by their guide. We are running behind accuracy. Accuracy has been increased, efficiency has been increased, but it is not getting done. So for the sake of research, you are doing it, it is not a good way. So authors, researchers, and guide should encourage all the researchers. So whether this is not getting the right efficiency, just show me the different way to approach it. That's my request to all of you. This is not a conventional method, but I have been doing this right from my study time, right from my studenthood time, and I am still doing it with my research scholars also, and it is very much working. It is not a bookish knowledge, but it is very much working. It is a right research for me. Okay, Preeti has asked that Alzheimer and metro be a little bit different, so we can use that. Preeti, you can use that, but you cannot compare that. You can write a review paper over that, but you cannot compare and get better accuracy or something like that. It was not ethical to say that this is getting better accuracy, right, Preeti? That's why I have said that we need to work on some algorithm which have been developed by ourselves also, not like review or something. Even if what Preeti you have saying, you have to do it for a review paper, and it can be published in a very high impact factor journal if it is a very good review, trust me. Fine. So Nature or I mean having a 10 or 12 point impact factor journal, so you can stimulate it, you can simulate it actually, Preeti. I'm not talking about that we have to write what Preeti has done, what Deepak sir has done in 2 years. You have to analyze all the data. Even if you will go through with review papers, you will find simulation and everything, but you cannot challenge any other work that Abhishek has done this wrong and I have improved the accuracy. What happened ethically, when Abhishek got to read your paper, he will challenge you that please prove it. Then you will stuck it into it. So if it is legal enough, if it is something you are confident enough of it, then go ahead for it. But the parameters should be same. I still repeat, the parameters should be same. Fine, Preeti. Okay, thank you. So thank you, everyone. Any other question, please ask. I'm overwhelmed with your response. Thank you, everyone, especially Deepak sir, Preeti ma'am, Kalyan sir, whoever have been asked the questions. Manikraj sir. Fine. So thanks again to college management and the college fraternity. A special thanks to Professor Anand, who has been very good friend of mine, and he has been working with me for last few years. So thanks again, sir, for such a beautiful event again. And thank you very much, Suvarna ma'am, Rijwan sir. I would like to join if anything like that we can do. Thank you, Preeti. Thank you, Jude. Thank you. Thanks a lot. So